Now that we know that only one-to-one functions have an inverse function, we will define inverse functions more explicitly. So if a function f takes a value x to the value y, then the inverse function g must take the value y back to the value x. So we apply a function, get to a new value, but then we want to reverse that to get back to our starting value, so we have to apply this inverse function g to do that. So here's a mathematical definition of an inverse function. Let f be a one-to-one function. The function g, denoted f inverse of x, and the inverse is denoted with this superscript of a -1, is the inverse of f provided the following statements are satisfied. That f composed with g of x is equal to x, and g composed with f of x is equal to x. So there are those compositions that we love so much, but this is saying that if we start with the function g, apply f to it, we're going to get back to what we started with. If we start with the function f, apply g to it, we'll get back to what we started with. So to determine if two functions f and g are inverses of one another, we find their compositions. If both compositions yield x, then f and g are inverse functions. So again, that f composed with g of x is x, and g composed with f of x is x. Note that if g is the inverse of f, then f is also the inverse of g. The domain of f is the range of g, and the domain of g is the range of f. In this example, we will determine if the two given functions are inverses of one another. In example A, we have f of x equals 8x plus 3, and g of x is equal to 1/8 x minus 3/8. To determine if these are inverses, we want to find their compositions. So I want to find f composed with g of x, and also g composed with f of x. So f composed with g of x, recall, means to do f of g of x. And this is f of, now I'm going to substitute g, which is 1/8 x minus 3/8. But f of anything says to do 8 times whatever I'm substituting plus 3. This then is 8 times 1/8 x minus 3/8, it's all in parentheses, plus 3. When I distribute by the 8, 8 times 1/8 is just 1x, minus 8 times 3/8 is minus 3 plus 3. This simplifies to just x. So far, this looks good. G composed with f of x means to find g of f of x. So this time I'm going to substitute the function f into the function g. So I want to find g of 8x plus 3. But g of anything is 1/8, whatever I'm substituting in, then minus 3/8. So I'm substituting in this 8x plus 3. 1/8 times 8x is just 1x or x. 1/8 times 3 is plus 3/8, then minus 3/8, and this is equal to x. Because both compositions give me x, this means that f and g are inverse functions. Let me explain this in a little bit of another way. So we see that f of x is 8x plus 3. G of x is 1/8 x minus 3/8. Because those have the common denominator, do you recognize that this is equivalent to just really x minus 3 all divided by 8? And so what I see is that the function f multiplies some number by 8, and then it adds 3. So think about that. We multiply by 8, and then add 3. Well, the function g says we start with the number x, we subtract 3, and then divide by 8. So can you see that we are reversing the operations and also the order, right? We have to kind of undo what we did in the reverse order to get back what we started with. And so this is exactly what we see with these functions f and g. In example B, we have this function f of x equals 5 divided by x, and g of x is equal to 5 divided by x. So this is a case where we're going to test to see if a function is its own inverse function. We would still have to find the compositions f composed with g of x and g composed with f of x. So just apply the definition of the composition first. This means to do f of g of x, which means to do f of, well, g of x is 5 divided by x. Now to do f of anything, I have to go back to my function, and it says to do 5 divided by whatever I'm inputting. So this is going to be 5 divided by what I'm inputting, which is the function g, which is 5 divided by x. This is a complex fraction. We can simplify this by remembering that division is equivalent to multiplying by the reciprocal. This is equivalent to 5 times the reciprocal of 5 divided by x, which is x divided by 5. And therefore, I get just simply x. G composed with f of x, likewise, is g of f of x, which is g of the function f, which is 5 divided by x. This is going to be the exact same thing, but I just want to go through the steps to make sure you understand. Now I'm saying g of something. G is take 5 and divide by that input, so this would be 5 divided by my input, which is 5 divided by x. So this is equivalent to 5 times the reciprocal, which is 5 times x divided by 5, or just x. So therefore, f and g are inverses of each other. And you can kind of see it if you want to think about it. Let's say f of 1, for instance. F of 1 is equal to 5 divided by 1, which is equal to 5. Now, for g to be the inverse, I need to be able to take 5 and get back to the 1. So if I do g of 5, I get 5 divided by 5, which is 1. So I applied f to it, got a number, applied g to that number, and I got back to the number I started with. So that's just a very simple illustration of how those two things are inverses of one another.